Welcome to the session on vectors, representing vectors. The objectives for this session are to use column vectors and carry out arithmetic operations on vectors. A vector can be described using its displacement or change relative to the x and y axes. This is called a column vector. For example, the diagram shows the vector a equals 3, 4. How do we multiply a vector by a scalar? When multiplying a vector by a scalar, each component must be multiplied by the scalar. So lambda times pq equals lambda p lambda q. When we add two vectors, we add the x and y components. So x1 y1 plus x2 y2 becomes x1 plus x2 y1 plus y2. Let's take a look at another example. Let a equal 3, 8 and b equal -1, 4. Find the values of the expressions shown on your screen. Pause the video and have a go. Press play when you're ready to view the solutions. So let's solve part A first. We are required to find 3a. So 3a equals 3 times 3, 8. We multiply the x and the y components by 3. So 3 times 3 and 3 times 8. To give 9, 24. And now for part B. Let's solve this. A plus b equals 3, 8 plus -1, 4. Add the x components and the y components to give 2, 12. And finally for part C, let's solve this. 3a minus 4b looks like this. Multiply a by 3 as shown and multiply b by -4, or multiply b by 4 and take it away from 3a as shown. To give 924 minus -416. To give 13, 8. Let's now take a look at unit vectors. A unit vector can be used to represent vectors in 2 dimensions. A unit vector is of length 1. Unit vectors along the x and y axes are denoted by I and j respectively. So I equals 1, 0 and j equals 0, 1. Here's I and here's j. What do 2-dimensional vectors pi plus qj look like? Let's take a look at an example. Here's the vector AC. The x component is 3i and the y component is 2j. By the triangle law of addition, we have AC equals AB plus BC to give us the resultant vector 3i plus 2j. So here's AC, here's AB, which is 3i, and BC, which is 2j. Now in notation, for any two-dimensional vector PQ, we have that PQ equals PI plus QJ. Let's now take a look at another example. Pause the video and have a go. Press play when you're ready to view the solutions. So let's look at example 2a first. Let a equal 2i minus 5j and b equal 3i plus 6j. Find a third b. So let's solve this. Here's a third, and here's b. We now multiply out. So a third times 3i is I, and a third times 6j is 2j, as shown. So we have that a third b equals I plus 2j. And now for part b. We are required to add a and b. Let's solve this. So when solving a plus b, let's write them out first. So here's a, and here's b. Then add the I component, so 2i plus 3i, and the j component, so minus 5j plus 6j, to give 5i plus j. And finally for part C, we are required to find 3a minus 5b. So let's solve this and write it out first. Here's 3a, and here's minus 5b. Expand first. So here's 3 times a, expanded, 6i minus 15j. And here's minus 5b, expanded, minus 15i minus 30j. So collect the I terms together to give 6 minus 15i, and the j terms together to give minus 15 minus 30j. This gives us minus 9i minus 45j. And now for example 3. Pause the video and have a go. Press play when you're ready to view the solution. So let's solve this. We are required to draw a diagram to represent the vector 4i minus 3j. Write this as a column vector. So 4i minus 3j as a column vector is 4 at the top and minus 3 at the bottom. In other words, 4i across and 3 down. This is the vector 4i minus 3j. Here's 4i, here's minus 3j, and here's the resultant vector. And now for example 4. Pause the video and have a go. Press play when you're ready to view the solution. So let's solve this. Given that a is equal to 4i minus j, b is equal to 3i plus 5j, and c is equal to minus I plus 7j, find a plus b plus c using column vector notation in your calculations. So we convert first all the vectors into column vectors. Here's A, 4, minus 1. Here's B, 3, 5. And here's C, minus 1, 7. And of course we're adding the three vectors together. Adding the x components gives 6, and adding the y components gives 11. To give us a vector 6, 11. So a plus b plus c equals 6i plus 11j. Now let's have a go at another example. Pause the video and have a go. Press play when you're ready to view the solution. So let's solve this. Given that a equals 2i plus 5j, b equals 3i minus 5j, find a minus 2b in terms of I and j. Let's solve this. Here's a, and here's minus 2b. So this is equal to a plus minus 2b, as shown. We've expanded the minus 2b. Now collect together the I terms and the j terms. So here are the I terms, 2 minus 6i, and here are the j terms, 5 plus 10j, to give us minus 4i plus 15j. This brings us to the end of this session. If you have understood its contents, you should be able to use column vectors and carry out arithmetic operations on vectors. Thank you very much for listening. To understand this topic in greater depth, do attempt the exercises in your textbook related to this topic.